Okay, so you're here because, let's face it, you want to really understand this whole data set thing, right? It's everywhere these days.
Yeah.
But who's got time to wade through all the speak?
Exactly. You hear the term, but what's the actual deal? Like, what are the different flavors, and how do you work with this stuff without pulling your hair out? Luckily, we've got this great Rebrowser article, What is a Data Set? It lays things out really well, definition, types, and best practices for data success.
Perfect. That's what we're diving into today. Data sets. They're kind of the backbone of, well, a lot of things,
Huh.
from how businesses operate day to day to, all the AI advancements we keep hearing about. It's fascinating stuff. And speaking of fascinating, the Rebrowser article even talks about all the ways data gets into data sets. Like meticulously gathering information or even using APIs to blend different data streams together. Okay, so let's just cut to the chase. What is a data set? Straight up.
Imagine a super organized digital filing cabinet. That's a data set. It's a bunch of related information, but the key is it's structured. It's not just random bits and pieces. It's arranged so you can actually analyze it and, make sense of it. The Rebrowser article calls it a digital container. I like that
Oh,
analogy.
yeah, it's not just a digital junk drawer. There's a system to it. And according to our source, there are some basic parts, some core ingredients that go into making a data set. Can you break those down for us?
Sure thing. The article highlights 4 key pieces. So first up, you've got variables. These are the specific things you're measuring, like a customer's age or the price of, I don't know, a coffee, or even like a sensor reading for temperature, whatever characteristic or attribute you're interested in.
I got it. So variables are like the things we're tracking?
Exactly. And then you have observations. These are the individual data points. Like, say you've got a sales database. Each individual sale, that's an observation. It's like each entry in your filing cabinet. Okay. So if I'm picturing a spreadsheet, each row would be an observation and each column is a variable.
Spot on. Then we have metadata. This is like the label on your filing cabinet. Information about the data set itself, like where did the data come from? What's the structure like? How should it be used? That kind of stuff.
Okay, so it's like the instructions or the context for the data.
Right. And then finally, we have the schema. This is like the underlying blueprint that defines how all that data is organized within the data set. It says this is how everything fits together. It's the architecture of our digital filing system.
Got it. So the schema lays down the law, the rules of the game. Okay, so now the Rebrowser article also dives into different types of data sets. This is where it can get a little confusing. Help us make sense of the main categories, would you? No problem. Our source breaks them down into 3 main types: structured, unstructured, and then kind of a mix, semi-structured. Let's start with structured data sets. It's probably what most people think of when they picture data. Information organized in a really predictable way, usually in those nice, neat tables, rows, and columns.
Good old spreadsheets and databases. The comfort zone.
Exactly. And the article gives some great examples, like a customer database with, names, addresses, purchase history, or financial transaction logs. Each entry has the date, amount, transaction type, all that good stuff. Even data from sensors that, consistently report temperature or pressure readings, they all fit the structured mold. Or even product inventory databases with the S key, quantity, price, all neatly organized. The key here is that the format is consistent and predictable. Everything's got its place.
So, nice and tidy. Everything in its little box. Now, unstructured data sets sound like the opposite of that, like pure chaos.
Pretty much. Unstructured data is all the stuff that doesn't fit into those neat rows and columns. It's more free-flowing, no predefined structure. The Rebrowser article gives some great examples here, too. Social media posts, for instance. You've got text, images, videos, emojis, hashtags all jumbled together. Or email content, varying formats, attachments, whatever people decide to throw in there. And then, of course, audio recordings, image files, videos, tons of information, but it's not organized in a way that a computer can easily understand.
Yeah, analyzing a structured database of purchases is one thing, but trying to make sense of millions of tweets or hours of video footage, that's a whole different ballgame.
Exactly. You need different tools and techniques for that. And then there's that middle ground, semi-structured data sets.
So semi-structured, a little bit of order in the Wild West.
Right. It's like a hybrid. Semi-structured data takes elements of both structured and unstructured data. It has some organization, which makes it easier to work with, but it's not as rigid as a fully structured database. The article talks about things like JSON documents, XML files. They use tags and hierarchies, so there's some order, but the actual data within those tags can be all over the place. Log files are a good example. They record what's happening in a system, but the actual content can be really varied. Same with NoSQL databases. There's a general format, but the entries themselves can be quite different.
So it's like having some labels and, general guidelines, but not strict rules for every single piece of data. Okay. Now, the Rebrowser article makes a big deal about this. Simply having data sets isn't enough. You need to manage them well. Why is good data set management so important?
Because, think about it, any analysis you do, any decisions you make based on data, it all hinges on the quality of that data. If you're working with messy, inaccurate, or poorly documented information, well, your insights are going to be flawed, and that can lead to bad decisions. It's like trying to build a house on a shaky foundation.
Yeah, the old garbage in, garbage out principle. So how do we keep our data foundation solid? What are some of the key practices here? The article lays out a few really important ones.
It does. The first big one is data quality assurance. This is all about making sure your data is accurate, complete, and consistent. The article really stresses the importance of the ETL process: extract, transform, load. It highlights things like regular data validation and cleaning to catch and fix errors. Standardizing how data is entered is huge for preventing problems in the first place. And using automated quality checks can really help you catch issues early on. Oh, and documenting everything you do, your entire data quality control process, that's vital. It helps everyone understand how things are being managed.
Right. And the article even gives this practical example, using Python code to check for outliers in numeric columns. It's a really neat illustration of an automated quality check.
Yeah, totally. It's all about putting systems in place to make sure your data stays clean and reliable. The second best practice they highlight is documentation and metadata.
We talked about metadata before, but why is having good documentation so crucial?
Think of it this way. Data sets often outlive the people who originally created them. So good documentation is like a guidebook for anyone who needs to use that data in the future. The article talks about data dictionaries, explaining what each variable means, information about the data source, how it was collected, any processing that was done, usage guidelines, all that stuff. Without good documentation, a data set can be a real nightmare to work with.
It's like inheriting a vintage car without the owner's manual. You might be able to get it running, but who knows what all those buttons do.
Exactly. And then the third best practice is version control and governance. Might sound a bit technical, but it's really about making sure your data is consistent and, well managed.
So, like keeping track of different drafts of a document, knowing which one is the most recent and what changes were made.
Yep. You need a good system for tracking different versions of your data sets so you can see what's changed over time. And of course, access control, permissions, making sure only the right people can access sensitive information. And then staying on top of all the data protection regulations.
Makes sense. So this is all good in theory, but what about real-world examples? How does effective data set management actually play out in practice? The Rebrowser article has some really interesting case studies that show us just that.
Yeah, they do. The first one focuses on healthcare analytics. So this healthcare provider, they really got serious about managing their patient record data sets, and the results were amazing. They managed to reduce diagnostic errors by 30%. That's huge, right? Like a real impact on patient care. They also use predictive analytics to, spot potential health risks earlier, and they streamlined all the reporting processes, saving tons of time and resources.
Wow, a 30% reduction in errors. That's a game changer. What about this second example?
The second one looks at e-commerce. So this online retailer, they focused on managing their customer behavior data better. And by doing that, they boosted their conversion rates by 25%. That means more people who visit their site actually made a purchase. They also cut down on cart abandonment by like 40%, which is a huge problem for online businesses. And on top of that, they got much better at managing their inventory, making sure they had the right products in stock.
Okay, so both of those cases really show how powerful good data set management can be. It's not just about theory, it's about tangible results. Now, of course, to actually work with data sets, you need the right tools. The Rebrowser article lists a few that are pretty popular.
Yeah, it does. For Python users, Pandas is like the go-to library. It's great for manipulating and analyzing data. Then you have platforms like Databricks. They give data scientists and engineers a shared space to work together. Snowflake is another big one. It's a cloud-based data platform that's really scalable and easy to use. And for machine learning, TensorFlow datasets is a treasure trove. It's a collection of ready-to-use datasets for training and experimentation.
Nice. So there's a whole toolbox out there.
Mm.
Now, looking ahead, what are some of the emerging trends in dataset management? The Rebrowser article touches on a few things that are pretty exciting.
Yeah, it's a really dynamic field. One trend is automated dataset generation using AI. Imagine AI that can just create synthetic datasets for testing and development. That would be wild. Then there's edge computing, which is all about processing data closer to where it's generated so you can do real-time analysis.
Hmm.
That's huge for the Internet of Things, all those connected devices. Federated learning is another big one. It's a way to train models on data from different sources without actually sharing the data itself, which is great for privacy. And of course, blockchain is being explored for tracking the history of data sets, making sure everything is transparent and trustworthy.
Wow, these all sound pretty transformative.
Oh.
Okay, before we wrap up, the Rebrowser article has an expert tip from Dr. Sarah Chen. What's her key piece of advice?
She says, the quality of your data set directly impacts the success of your AI initiatives. Invest time in proper data preparation and validation, which really just underscores everything we've been talking about. Data quality is paramount, especially as we move towards more and more advanced applications like AI.
Absolutely. The article also gives some general recommendations for success with data sets. What are the main takeaways there?
Well, they echo a lot of what we've already discussed. Have clear objectives from the start. What are you trying to achieve with your data? Make sure you have robust quality control measures in place. Think about scalability from the get-go. How are your data needs going to evolve over time?
Those are all really important points. Now, the article also touches on some common challenges when working with data sets and some potential solutions. What are some of the hurdles people typically face?
Data quality issues are a big one. The article suggests building automated data validation pipelines to address that, which again ties back to that Python example we talked about earlier. Then there's the issue of scale. How do you deal with massive data sets and keep everything running smoothly? The article recommends using appropriate data structures and optimization techniques. And of course, privacy and security are always concerns. Data anonymization and access controls are key for tackling those challenges.
Those are all very real practical issues. It's great to have some solutions in mind. Now, one last thing. The Rebrowser article has this really interesting section called From the Field, Developer Perspectives. It shares insights from people who actually work with data sets every day. What do they have to say?
This section is really insightful. One thing that came up again and again was the importance of understanding the business context before you even start collecting data. One analyst put it really well. Start with the question you're trying to answer and then gather the data. Don't just collect data and hope you find a question later. Makes sense, right?
Oh, absolutely. Don't just collect data for the sake of it. Have a purpose.
Right. Another common piece of advice was to always make working copies of data sets before you start messing around with them. Just good practice. There was also a lot of talk about tools for initial exploration, like pandas profiling and SuiteViz. They're great for getting a quick overview, but they can be a bit resource-heavy for huge data sets. Performance optimization was another big theme, using specialized CSV readers for large files, adopting more efficient file formats like Parquet, and then, of course, managing resources, especially memory, when you're dealing with tons of data, working with samples, optimizing data types, things like that. And a really consistent message was the importance of thoroughly exploring and preparing your data before you jump into analysis.
Oh, and one last thing, something that came up quite a bit was the frustration of dealing with poorly documented data sets in the real world.
Yeah, it's a good reminder that things aren't always perfect in practice. Sometimes you have to get creative. Okay, so to sum it all up, what's the big takeaway from our deep dive into the world of data sets? Well, as the Rebrowser article says, data sets are the foundation of modern data science and analytics. If you want to be successful in this field, you need technical skills, for sure. But you also need a strong grasp of good management practices. Data quality and security are absolutely crucial. And by following those best practices we've been discussing, organizations can unlock the true potential of their data.
Couldn't have said it better myself. And for anyone who wants to dig deeper, the article lists some great resources. Kaggle datasets, data.gov, the UCI machine learning repository. Lots of great places to continue learning.
Definitely. There's a whole world of data out there waiting to be explored.
So next time you're looking at a spreadsheet or you hear about those massive AI datasets, remember our deep dive. Think about how even the simplest collection of information, when it's organized and managed well, can lead to incredible insights. It might just change how you see the data all around you. Thanks for joining us.